Hello there. Wait, don't pause.
There you go.
Hello there. Are you having trouble drawing the orbital overlap diagram? Well, I'm here to help you ace that part on the quiz or test. Today, I'm going to teach you how to do the orbital overlap diagram of CO2. So the Lewis structure of this would be where oxygen has two lone pairs. Each element fills up its octet. And so we're going to start with the hybridization of C. C, initially, its valence electron, has a configuration of and that's going to be S2P2. And since there are no lone pairs on C, we're going to promote this one over to this side. So then we're going to have a second state of 1s and 3p's as such. However, we know that C actually has not one but two pi bonds for either O. So we're going to cut it here and leave these two unhybridized so that we save them for the pi bonds. And we're going to hybridize these two, and together they make SP. So that's the hybridization of C. We're going to come back to this later. And so now it's time for the hybridization of oxygen. Oxygen's valence electron configuration is as such. S2P4. Now, because oxygen has two lone pairs, this and this correspond as that. So we will not promote any electrons in this case. And since also oxygen has one pi bond, we will discard one electron in the sense that it will remain unhybridized. And this one will form the one sigma bond here, and the pi bond corresponds to that. So the excited state would be S2 as such, and this will be known as sp2 with one unhybridized electron. sp2, sp. And now we are going to begin drawing CO2. So we're going to start with our central atom, C. Now, we know that C has two sigma bonds and two pi bonds. So we're going to start with the sigma bond. We're going to draw something like that, and it's going to connect to the sigma bond of an oxygen. So we're going to draw something else like that. This comes to an oxygen, and inside the overlap of the both orbitals, we put two electrons. That's the first step. That's easy enough. We know that this hybridization of the sigma bond of C is sp. So we're just going to write a little sp in there. And we know that the hybridization of the O bond for sigma bonds is sp2. So we're going to draw sp2 in there as such. We also know that for each oxygen has two lone pairs. So we're just going to draw something like this. We're going to draw the electrons in there. And we're just going to mark it LP, LP for lone pairs. Similarly, we also know that carbon has a pi bond. And this is the way you draw a pi bond. You write 2p in the bottom and an electron going in one direction here. Now, this pi bond is with O, and it's going to be in the y planar, whereas these ones are in the x. So this one's going to correspond like that. We're also going to draw 2p, and instead of writing it up like that, we're going to write it down like that. And we're going to connect it with this line, and we're going to mark pi bond, and over here, right on top of the overlap, we're going to mark a sigma bond between the sp and the sp2. The exact same thing is done on the other side. However, there is a slight twist where we will get into soon. Once again, I'll just erase this, that way we'll have a little more room, but I'll rewrite it here. And that's going to be like that. And we're going to draw the electrons in there. Not to forget to mark it as a sigma bond. The hybridization is sp for carbon, sp2 for oxygen, And so we are now going to draw the pi bond corresponding this oxygen with this carbon. However, we cannot use anything in the x plane for it is already taken, and we cannot take anything in the y plane for it is already taken. So we now have to create a z plane for the pi bond, which could get a little difficult when trying to draw, but we simply, with dotted lines, go around like this to give a sense of perception. And we're going to mark this 2p, and this is also going to be at the top. And we're going to create something with parallel like that, just to give a little dimension like that. And we're also going to call this 2p, but this one is going to be facing downwards. And we're going to be drawing a connecting line and mark it pi, and draw a connecting line and mark it pi. Now this O also has two oxygens for its part, two lone pairs that is. We draw the lone pairs inside, mark LP, LP, and this is your orbital overlap diagram for CO2.